Alright, in this lesson we're going to take a look at one of the things that come up a lot. We're going to use it for years and years and years. We're going to look at the absolute value. Alright? So just get started with the basic idea of it, and then we're going to move into equations, and then of course we're going to move on to inequalities. But this one will be all about the equations, okay? So first thing you have to know is what the heck's an absolute value? It's those little straight lines down like that, usually a number in there, okay? And the absolute value of a number, n, is actually the distance between the graph and the number n and 0. In other words, how far is it away from the number 0? Okay, so if we take a look at the absolute value of 3, okay, here's 0 and 3. 1, 2, 3. This is 3 spaces. Okay. Well, similarly, we can take a look at negative 4. 0, 1, 2. Negative 4 is here. If we take a look at this distance, that distance is 4 units. Notice how it's a positive number, right? Basic rule of thumb is if your absolute value is positive, it stays positive. If it's negative, you make it positive. Don't flip it to its opposite. It's not like that. The absolute value of 0 is 0. It doesn't go anywhere. It stays where it is. It's where it's going to be. Always is 0. Okay. All right. So how are we going to use this? There is one other definition. You know, the absolute value of a number n is algebraically defined at n if n is greater than or equal to 0, or negative n if n is less than 0. In other words, positive stays the same, and if it's negative, a negative number, the absolute value of a negative number becomes positive. So in other words, see how it's negative n? If you had negative 2, the absolute value of that, it would go into this equation. So negative 2 becomes positive 2. We have Fusoya over here from Final Fantasy VI. If you're technically Japanese, no, actually it's 4. Wow, terrible. 6 is the better one, anyways. The end. He's from the moon. Pretty cool dude. All right. Side note. All right. The way we're going to use this, we're going to use this for equations. Okay. Using our example above, the absolute value of x equals 2 illustrates the point. Since the absolute value of some real numbers x equals 2, that number could be 2 or negative 2. In other words, think about it. What's the absolute value of 2? Well, it's 2. Or what's the absolute value of negative 2? It's 2. Okay, so there's always two solutions to it. And that's why the algebraic definition comes in handy. It also comes in handy, especially when you're doing piecewise functions and derivatives of it. All right, so let's talk about the equation. Okay, so when we have an equation with an absolute value, we're going to get two solutions, usually. Notice how I say usually. Okay, so the absolute value of x equals k. If k is greater than or equal to 0, it's equal to itself without the absolute value on it, x equals k, or it's the negative of it. Okay, so you get two solutions. Notice how I say k is greater than or greater than 0. What happens if you have an absolute value equal to a negative number? We're going to get to that question in a little bit. Okay, and you're going to see, guess what? Can it happen? Think about it. Can't happen. Notice when you graph the solution set of an absolute value, you are really graphing two little solutions. Okay. Of the solution of two simple sentences. In other words, you got to do both. Right. Let's take a look at some of our procedures so we get them. Number one, always isolate your absolute value. You get the absolute value on one side of the equation, everything else on the other side. You want it to look like the absolute value of x was the absolute value of x plus 3. Everything, it's just equal to something. Okay. Then after that, you set the expression in the absolute value to two separate things. You can have one or the other. It can be both of those. And then the third thing is solve. It might ask you to graph it, and that's just put points or for inequalities. But there's also a fourth step, okay? And that is you're gonna need to check. Okay? You need to check. Check. So that's step 4. Add that in there. All right. So we start with the easy one. The absolute value of x equals 5. Well, isolated. Set it equal to a number. You're going to branch it off into two things. It's equal to itself, or it's negative. You're going to graph it. Here's negative 5, and here's 5. It would just be two simple circles. All right. So easy peasy. All right. So this one, as you can see, we haven't had the absolute value by itself. It's got an extra stuff on it. We have to get this alone. So you got to get rid of -5. You add it to both sides. To get the absolute value of x equals 3. Now we have an absolute value equal to a number, so that's when we split. We have x equals itself without the absolute value there, and it's equal to its negative. Okay? Just -3, 3, there's our solution right there. There are two solutions to this. Okay? And if you check it, 3, the absolute value of 3 is 3 minus 5, which is -2. The absolute value of -3 is 3. So 3 minus 5 is -2. All right, move along to the next ones. Okay. M minus 3's absolute value equals 7. Notice how the absolute value is already by itself, right? Nothing on it. That's all it is. The absolute value part is already isolated. So at this point, we do our split. Okay, so you have M minus 3 equals 7, or M minus 3 equals -7. Okay, so let's take a look. Add 3 to both sides here, and you add 3 to both sides here. Okay. Notice how I had it equal to itself, and then one where it was its opposite, it's equal to the negative. M equals now 10, or M equals -4. All right, so a little different. -4, 10. Okay, those are our solutions. So you have two possibilities. And if we check them, -4 minus 3 is -7. The absolute value of -7 is 7. 10 minus 3 is 7. The absolute value of 7 is 7. Okay. So you can see we have no problems there. All right. Last but not least, okay, we have this one right here. Notice how we already have the absolute value isolated. So we set it equal to the same thing without the absolute values, or we set it equal to its negative. All right, solve both equations. You're going to be solving the same thing. Just be careful. Watch your signs. You add 5 here. You add 5 here. You get 3m equals 12. And you get 3m equals, luckily, what is -7 plus 5? That's 2. Didn't come out nice. Divide by 3 on all of these. You get m equals 4. That one's nice. And m equals 2/3. Not nice. That's okay. 4 2/3. Oops. Let's make sure I can read that. That's me. Oh, undo. There's somewhere here. New little list. There we go. There's my eraser. Back in action. We have 2/3, and we get a double solution set. Okay, we can check both of these. 4 times 3 is 12. Minus 5, that's 7. 2/3 times 3 is 2. 2 minus. Okay. 2 minus 5. Okay. Now if you look, I'm wrong. What did I do wrong? Lost our signs. For your negatives. Now just think about it. You'll get -2/3 times 3, which is going to be -2 minus 5 is -7. Absolute value of -7 works. Okay. See, check. I make mistakes all the time. Okay, but it's good for us, right? So far, we're not having any problems. Okay. Let's take a look at what else we have. Okay. We are going to now look at the exception. This is why the check is a big deal. Okay. You cannot take the absolute value of a number and get a negative result. The absolute values of numbers are always supposed to be positive. Distances are always positive, so absolute values better be positive. Right? Now, don't mix this up, because you can have an answer equal a negative number. It's just when you isolate this statement, it doesn't have an answer. Right? If you do solve, sometimes it will happen, and that's why the check is a big deal. Right? Let's take a look at this one right here. Right? The absolute value of x plus 3 equals 2x. Add or subtract 3 from both sides, you get this. This is where we split. Okay? It equals a positive and then a negative. Notice how we take the negative of the whole thing from all the sides. You get two answers. Okay? Yeah, subtract 2x here, and you get -x equals -3, and then you get x equals 3. Over here you get negative 2x plus 3. Add 2x, you get 3x equals 3. Divide by 3, you get 1. Alright, check them both. Look. Try 3. 3 plus 3 is 6 there, and 6 there. 1, 4. Well, this is 2. These are not. Okay, so it didn't work. Okay, so that's why I have to check. There is only one solution. It's just 3. Okay, it can lead to that false answer. Okay, so we have to check and make sure. We have a couple more to go. Let's take a look at these. Solve and graph. We'll just solve them if we have to. We can graph it if we need to, but they're not too much. Right? Notice how the absolute value is already isolated. So all we have to do is split the two different problems. X equals negative 3. Notice how you just make that whole thing negative. So solving is always going to be pretty much the same. Okay. Add x here. Add x here. So that's 4 equals 4x. X equals 1. Add x here. You get negative 2x equals 4. And we get x to equal negative 2. Check them. 4 minus 1 is 3. It's 3. So that equals 3. We try negative 2. 4 minus negative 2 is what? Plus plus 6. Absolute value of that is there. And if you notice on the other side, we get negative 6, which is not true. That is a false answer. So, delete, bye-bye. We reject, and our final answer is just x equals 1. Right? Last but not least, let's take a look at this one. Again, it's already isolated, so we don't have too much work to do. Split. Y minus 1 equals 3y, and y minus 1 equals negative 3y. Do some solving, subtracting y's. Okay. Watch out so your y's don't look like 4s. Y. Okay? I like to make them loopy. That'll help. Alright, so subtract y, get negative 1 equals negative, or positive 2y. That one. And on the other one over here, we're going to get, subtract the y, and we get negative 1 equals negative 4y. So you get y to equal negative 1/2, and y to equal 1/4. Okay. So far, let's just do our check now. I'm going to make sure I solve this 1/4 and negative 1/2. So let's see what happens. We try half. Y minus negative 1/2 is negative 3/2. And its absolute value is 3/2. Well, if we try over here, 3 times negative 1/2 is negative 3/2. Not true. Okay, so that's a falsehood. Alright, let's take a look at 1/4. 1/4 minus 1 is negative 3/4. And its absolute value is 3/4. And then 3 times 1/4 is 3/4. So our solution is just that one there. This one is a big reject. Okay. So one of the biggest things we have to do is check, check, check. So procedurally again, isolate your absolute value, split it into 2 sections, solve both of those, and then check it. All right. You have a great day.